As part of the preliminary cockpit preparation, you will check that the flap position agrees with the lever position, the speed brake lever is in the retracted position. Warning: if a flight control surface position does not agree with the lever position, check with the maintenance crew before applying hydraulic power. During the walk-around, you should ensure that all the flight control surfaces are undamaged and free of any contamination, e.g. snow or ice. The same check is performed on each side of the aircraft. During cockpit preparation, the only check associated with the flight controls is to ensure that all flight control computers' push buttons are in the lights out configuration. Notice that before engine start, the bank angle protection indicators are displayed in amber on the PFD. The side sticks are inoperative because there is no hydraulic power. Moving the side sticks will not affect the control surfaces. Before pushback, for your own comfort, it may be necessary to adjust the position of the seats and the armrests to easily handle the side stick. This is done by using the seat electrical controls and the armrest control knob. In the same way, it may be necessary to adjust the position of the rudder pedals. This is done using the rudder pedal adjuster. After engine start, the ground spoilers are armed by pulling the lever up. Lift the speed brake lever. A white band appearing around the base of the speed brake lever and the green memo "Ground spoilers armed" on the engine warning display indicate that the spoilers are now armed. Next, the rudder trim is zeroed by pushing the reset push button. Reset the rudder trim. The trim is now reset to 0. This is checked on the rudder trim panel. It can also be seen on the ECAM flight control page via a blue line displayed below the rudder scale. Note: the rudder trim rotary switch is isolated during flight with the autopilot engaged. The takeoff memo normally appears during taxiing. For training purposes, we have displayed it now. The flaps should be set to their takeoff position, 1 plus F, 2 or 3. While the flaps are deploying, we will be looking at their indications on the engine warning display. To set the flaps, you need to lift up the lower part of the flap lever and then position it to the appropriate setting. Here, as an example, we will select flap 3. Select flap 3. As soon as a flap selection is made, blue markers appear on the engine warning display to show the selected flap and slat positions. A blue number shows which flap position has been selected, here 3. The word flap appears in blue. Also, as soon as a flap selection is made, the current slat position green markers move, followed by the flap. The white labels S and F appear. When the flaps and slats have reached their selected positions, all position indications turn from blue to green. The word flap changes from blue to white. The flap's takeoff memo on the engine warning display turns to green. Takeoff trim is set manually using the trim wheels. The pitch trim values are indicated on the scales beside the trim wheels. The takeoff trim has to be in the green range. Select either pitch trim wheel. The pitch trim position set may be seen on the ECAM flight control page during the flight control check when taxiing if required. The after start sequence for flight controls is complete. When the flaps are extended, the ailerons are dropped by about 5 degrees in order to increase lift. The aileron indexers are now pointing to a small white square, which represents the new neutral position. A flight control check is completed at a convenient on the PFD. The combined side stick deflection indicator is displayed on the ground as a white cross. The cross only indicates side stick deflections and does not indicate control surface position. The green bank angle protection indicators have also appeared, indicating normal law, as the aircraft is hydraulically powered. The side sticks become operable after first engine start, as soon as hydraulic power is available. On ground, the control surfaces respond in direct relationship to movements of the side sticks. This is the ground mode. As it is not possible to see the flight control surfaces from the cockpit, the reaction to side stick or rudder pedal movement is monitored on the ECAM flight control page. The page is automatically called when either of the side sticks or either of the rudder pedals are moved. We will start the flight control check with the elevators by moving the side stick to its full back position. Move the side stick. The pilot non-flying checks on the ECAM page that the elevators have moved to their full up position. Move the side stick fully forward. The elevators have now moved to their full down deflection. Move the side stick back to neutral. With the side stick neutral, ensure that the elevators have returned to the neutral position. The flight controls are working in pitch. We will continue by checking the roll control. Move the side stick full left. You can see on the ECAM that the left aileron has moved fully up, the right aileron has moved fully down. The roll spoilers on the left wing have extended. Move the side stick full right. Now you can see that the left aileron is fully down, the right aileron is fully up, the right roll spoilers are extended. Move the side stick back to neutral. With the side stick neutral, ensure that the ailerons return to the neutral position and the spoilers are back in their stowed position. Now we will check the rudder. Before testing the rudder pedals, you need to press and hold the rudder pedals disconnected button on the nose wheel steering handle to prevent any unwanted steering inputs. press the pedal disconnected button. Now the rudder pedal movements will have no effect on the nose wheel steering. The right rudder pedal should now be pushed. Push the right rudder pedal. The rudder has moved to its full right deflection, so you should now push the left rudder pedal. Push the left rudder pedal. The rudder has moved to its full left deflection, so the pedals should be returned to their neutral position. Select either rudder pedal. The rudder has returned to the neutral position, so the pedal disconnect button should be released. Release the pedal disconnect button. The pilot non-flying would now check his side stick for full movement and correct control response. Because the rudder pedals are mechanically linked, it is unnecessary to recheck them. The flight control check is now complete. When the autopilot is engaged, the side sticks are locked in their neutral position, and the rudder pedals remain stationary. Neither will move regardless of any autopilot input. One of the first actions for the crew after gear retraction is to disarm the ground spoilers. This is achieved by pushing the speed brake lever down. Disarm the ground spoilers. The white band at the base of the speed brake lever is no longer visible, and the ground spoiler armed message has disappeared from the engine warning display. You are above acceleration altitude with the airspeed increasing. At or above F speed, minimum speed for flap retraction, the flaps can be retracted directly to flap 1. Retract the flaps to 1. Flap 1 is now set. Notice both slats and flaps are extended to the first position. This is 1 plus F configuration. The airspeed is increasing through S speed, minimum speed for slat retraction. Flap 0 would be normally selected at this stage. To demonstrate automatic flap retraction, we will delay this action. As the speed approaches VFE at flap 1 plus F, the flaps will automatically retract fully when the airspeed reaches 210 knots. Notice the slats remain deployed in their first position. This is configuration 1. There is no automatic retraction of the slats. Set flaps 0. Flap 0 is now set, which can be confirmed on the engine warning display. Notice that the slat flap indications have been simplified. The after takeoff actions are now complete. We will go directly to the descent phase. During descent, the speed brake may be used to increase the rate of descent to correct the flight profile from above or to slow down. During the initial approach phase, speed brakes may be used to increase the rate of deceleration. To use the speed brakes, You must first press down on the speed brake lever, which is spring-loaded into the retracted position. Push down on the speed brake lever. The speed brake lever can now be moved rearwards to any position, depending on the amount of drag required. With the autopilot engaged, the maximum speed brake deflection available is approximately half, even with the speed brake lever moved fully back. The speed brake retraction rate is reduced when flying at high speed. Move the lever to half position. For training purposes, we have called the ECAM wheel page for you to remind you of the indications. The indications are also shown on the ECAM flight control page. We are back to normal display. With some power on at least one engine, the speed brake message will flash amber. Retract the speed brake. The spoiler retraction can be confirmed on the engine warning display by the disappearance of the speed brake memo message. We have activated the approach for you. The airspeed decreases below the maximum speed for flap extension, or VFE, shown on the speed tape by amber dashes. Select flap 1. Notice that an airborne selection from flap 0 to flap 1 deploys the slats only. You cannot select flap 1 plus F from flap 0 in the air. The speed has now decelerated to below VFE for flap 2. Select flap 2. Flap 2 is set. At this point, before flap 3 is selected, we have lowered the landing gear for you. Arm the spoilers. No, click on the speed brake lever. The ground spoilers are armed, which can be confirmed on the engine warning display. Notice that as the landing gear is down, and as we are below 1500 feet AGL, the landing memo has appeared. Below VFE, flap 3 can now be selected. Select flap 3. Flap 3 is set. Although flap 3 may be used for landing, the normal configuration is flap full. Select flap full. Flap full is set, and the speed is constant at V approach, the final approach speed. You can check on the landing memo that the aircraft is now fully configured for landing. In normal law, passing 50 feet, the system memorizes the aircraft attitude. It progressively reduces this attitude. Therefore, the pilots have to perform a gentle flare, as for a conventional aircraft. At touchdown, with the main landing gear compressed, the ground spoilers deploy automatically and operate as lift dumpers, provided the thrust levers are at idle or reverse. Spoiler extension can be monitored by the pilot non-flying on the ECAM wheel page. Note, if only one main landing gear leg is compressed, the ground spoilers will extend partially, thereby decreasing the lift and compressing both main landing gear legs. Ground spoilers will then deploy fully. If a go-around is performed, the ground spoilers will automatically retract when the power is applied. As part of the after landing phase, the ground spoilers should be disarmed. Disarm the ground spoilers. The flaps should now be retracted. Select flap 0. This concludes the normal operation of flight controls. Let's first see the redundancy aspects of the flight controls. In case of a computer failure, the second computer of the same type takes over. ELAC, SEC and FAC cases. Note that SEC 3 is only used for spoiler control and does not participate, as SEC 1 and 2, in the flight control system reconfiguration. Each primary flight control surface is supplied by 2 ailerons, elevators and stabilizer, or 3 rudder different hydraulic sources. Each control surface has an independent actuator for each hydraulic source. Each actuator is controlled by a different computer. One actuator for each surface is always in active mode. The other stays in damping mode and is monitored by its associated computer. We will demonstrate these points in the following ELAC 1 failure. Assume you are the pilot non-flying. You are in flight and everything is normal. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. Observe ELAC indications on the ECAM flight control page. The 1 and the box of ELAC 1 are in amber. The 2 of ELAC 2 remains in green, indicating that ELAC 2 has taken over automatically. Indications for aileron actuators, controlled by ELAC 1, are partially boxed in amber. This means that these actuators have automatically switched to damping mode. Actuators controlled by ELAC 2 have automatically switched from damping to active mode to control the ailerons. They are not boxed on the ECAM flight control page. ELAC 1 fault light is illuminated on the flight control panel. We can see that the first action is to reset the faulty computer. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. ELAC 1 is now off. Continue ECAM action. ELAC 1 has not been successfully reset. The procedure requires you to switch ELAC 1 off. Continue ECAM action. After review and confirmation from the pilot flying, clear flight control. The status page is displayed for review. A green message advises us that we have a degradation in approach capability. Note that neither control surfaces nor maneuvering ability are lost. You can see in the Inoperative Systems column that ELAC 1 and CAT 3 dual are now inoperative. After review and confirmation from the pilot flying, clear status. ECAM actions completed. We will now review the other redundancy features and protections we did not have the opportunity to see when performing the previous procedure. In case of complete failure of ELAC computers, SEC2 computer takes over the control of the elevators and the trimmable horizontal stabilizer. The roll function is still available via the spoilers. The ailerons are in damping mode. In the very low probability of SEC2 failure, it will be replaced by SEC1. Another case of failure is an elevator fault. In this case, the deflection of the remaining one is limited to avoid excessive asymmetrical loads on the tail or rear fuselage and to reduce the asymmetry effects. The remaining surface is sufficient to resume normal flight. In case of total loss of normal control or hydraulic supply, the elevators are automatically set to and maintained in the neutral position. Provided the appropriate hydraulic systems are available, mechanical control of the trimmable horizontal stabilizer is always available via the pitch trim wheels. For the rudder, mechanical control via the rudder pedals is always available even in case of complete failure of FAC computers. This is called the mechanical backup. Summary. General rules. Summary. General rules. If a computer fails, the second computer of the same type takes over. Each primary flight control surface is supplied by at least 2 different hydraulic sources. An independent actuator is associated with each hydraulic source for each surface. Each actuator is controlled by a different computer. For a surface, one actuator is always in active mode, while the other or others are in damping mode. Ailerons, elevators, trimmable horizontal stabilizer, rudder. If both ELACs fail, SEC2 controls the elevators and the trimmable horizontal stabilizer. The ailerons are in damping mode. If SEC2 fails, it will be replaced by SEC1. In case of an elevator failure, the deflection of the remaining one is limited to avoid excessive loads on the tail and rear fuselage. Mechanical backup is always available using the rudder pedals and pitch trim wheels, provided the appropriate hydraulic systems are available. Let's see how the spoilers are controlled by the SEC. The spoiler control is shared by the three SECs. We will now see a spoiler fault. Assume that we are in descent, speed brake extended, and no previous fault has occurred. Retract the speed brake to activate the failure. On the engine warning display, read the title of the failure. Observe left spoiler 3 indication in amber on the ECAM flight control page. These indications mean that left spoiler 3 has failed in the extended position. The SEC, which controls this spoiler and has detected the fault, will automatically retract it and inhibit its symmetrical one on the other wing, right spoiler 3, also shown in amber. You can now observe on the ECAM flight control page that spoilers 3 on both wings are retracted and shown in amber. Note that when a spoiler has failed on one wing, the symmetrical one is automatically inhibited. As a general rule, spoilers are automatically retracted when faulty or not electrically controlled. As no action is required in the procedure, after review and confirmation from the pilot flying, clear flight control. The status page is displayed for review. A blue message advises us that we will have to calculate a new landing distance. This is due to the fact that both spoilers 3 will stay retracted when the remaining ground spoilers extend at touchdown. You can see in the Inoperative Systems column that spoilers 3 are now inoperative. After review and confirmation from the pilot flying, clear status. ECAM actions completed. We will now review the other spoiler aspects we did not have the opportunity to see when performing the previous procedure. In certain circumstances, speed brake extension can be inhibited. In these cases, the spoilers are automatically retracted and stay in this position until the inhibition conditions no longer exist and the lever is reset. A master caution and an ECAM procedure are also triggered. Each spoiler is fitted with a single actuator supplied by one of the hydraulic sources. In case of loss of hydraulic supply, an affected spoiler remains at its current deflection unless pushed down by aerodynamic forces. Summary. Spoiler control is shared by the three SEC computers. When a spoiler has failed on one wing, the symmetrical one is automatically inhibited. As a general rule, Spoilers are automatically retracted when faulty, inhibited, or not electrically controlled. Each spoiler is fitted with a single actuator supplied by a hydraulic source. In case of loss of hydraulic supply, an affected spoiler remains at its current deflection unless pushed down by aerodynamic forces. We have discussed spoiler faults. We will now see a double FC-DC failure. Assume that the aircraft has been dispatched with FC-DC2 faulty, as authorized by the minimum equipment list. Notice that the status reminder is displayed on the engine warning display. Call the status page. You can see that FC-DC2 is shown as inoperative. Select the flight control page. Observe, with a single FC-DC available, here FC-DC1, the ECAM flight control page indications are normal. Deselect the ECAM flight control page. Assume you are the pilot non-flying. You are in flight and, except for FC-DC2, everything is normal. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. Observe on the ECAM flight control page that the data normally supplied by FC-DC1 or 2 is no longer available for display and is replaced by amber indications or crosses. As recommended in the procedure, you will have to check the flight control computer status by monitoring the left and right flight control panels on the overhead panel. Here, as no fault lights are illuminated, all the other computers are working. As no action is required in the procedure, after review and confirmation from the pilot flying, clear flight control. The status page is displayed for review. A green message advises us that the flight control indications are lost. You can see in the Inoperative Systems column that FC-DC1 and 2 are now inoperative. After review and confirmation from the pilot flying, clear status. ECAM action completed. You have completed the second flight control abnormal module. Let's continue with the third episode. We will start with a SFCC1 flap channel fault. Let's assume you are the pilot non-flying. You are in flight and everything is normal. Click on the forward arrow to activate the failure. Note that there are neither audio nor visual warnings in this case. The title of the failure is displayed on the engine warning display. SFCC1 flap channel is faulty. As the flaps information is displayed on the engine warning display, no system page is called. We can see that the only action is to deselect the GPWS flap mode. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. GPWS flap mode is now off. After review and confirmation from the pilot flying, clear flight control. No, press either clear key. The status page is displayed for review. A green message advises us that we will have approach idle on engine 1. Notice the green information, flaps slow. When an SFCC flap channel is inoperative, the flaps are still available, but they will move at half speed. If the two channels of one SFCC fail, both slats and flaps will operate at half speed. You can see that no inoperative system is displayed in the Inoperative Systems column. After review and confirmation from the pilot flying, clear status. ECAM action completed. You are now in the approach phase, and the slats and flaps need to be extended. Flap 1 has been set, and you are ready to set flap 2. Set flap 2. On the engine warning display, read the title of the failure. Notice on the engine warning display that flap, F, and the flap triangle have turned amber, indicating that we have a flap fault. The amber F locked indication appears under the selected position to indicate that the flaps are locked. The white S and the green triangle indicate that the slats have reached the selected position. Notice the amber line, wing tip brake on. The wing tip brakes, WTB, are hydraulic devices. They lock the affected surface movement on both wings in case of asymmetry, overspeed, symmetrical runaway, or uncommanded movement. Note that they cannot be released in flight. If the flap's wingtip brakes are activated, slats operation is still possible, and vice versa. Notice you are restricted to slats 2 limiting speed. After review and confirmation from the pilot flying, clear flight control. The status page is displayed for review. The required landing configuration is flap 3, which will give maximum slat deployment. V approach and the landing distance will be increased to compensate for the locked flaps. Use the Quick Reference Handbook to determine the new V approach and landing distance. Information in green indicates that we will have the approach idle on both engines. You can see in the Inoperative Systems column that the flaps are inoperative. After review and confirmation from the pilot flying, clear status. ECAM action completed. You have seen a flap locked fault. Let's assume we have no failure. You are the pilot non-flying and we are in approach. Flap 1 has been set and you are ready to set flap 2. Set flap 2. On the engine warning display, read the title of the failure. Notice on the engine warning display that flap S and the slat triangle have turned amber, confirming that we have a slat fault. We are restricted to VFE flap 2. The action is limited to the recycling of the flap lever. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. The flap lever is back to 1. Set it again to 2. Perform ECAM action. The slat recycling has not been successful. Notice that in this case, the procedure steps stay on the engine warning display. After review and confirmation from the pilot flying, clear flight control. You can see that we are now in alternate law. The loss of the protections is confirmed on the PFD by the amber crosses at the roll and pitch limits. After review and confirmation from the pilot flying, clear flight control. The status page is displayed for review. A white Approach Procedure title shows us the procedure to apply for the approach, in this case, fuel pumps configuration, flaps and GPWS settings. The approach and the landing distance will be increased to compensate for the faulty slats. Use the Quick Reference Handbook to determine the resulting landing distance. Observe the confirmation that we are in alternate law and the reminder that we will go to direct law when the landing gear is extended. The approach capability is also degraded. You can see in the Inoperative Systems column that the flight control protections and the slats are inoperative. Both autopilots and the auto thrust are now unavailable. After review and confirmation from the pilot flying, clear status. ECAM action completed. We will now review some other slats and flaps protection features and indications. The flaps are fitted with a flap disconnect detection system. This system detects attachment failure and inhibits flap operation to limit further damage. In this case, you will get an alignment fault. The procedure is similar to the flaps locked procedure seen previously. The last protection feature is the slats alpha speed lock function. This function inhibits slats retraction at high angle of attack and/or low speed. It is indicated by an alpha lock pulsing blue on the engine warning display.